Okay, let us see how to solve the design examples on a regulated power supply. Now, one of the example we will solve today. Design a regulated power supply using LM317 for output voltage range from 5 volt to 15 volt and adjustable current is given as 100 microampere. Now, for any example or problem to solve, first step is you have to draw the circuit diagram. Now for this LM317 regulator, this LM317 IC is having 3 terminals. One is input voltage, another one is output voltage, and third terminal is adjustable terminal. So remember that to that adjustable terminal we are going to connect a variable resistor, and one of the fixed resistor is connected here, that is called as R1. So R1 and R2 are necessary in case of LM317 and 337. So remember that this is a variable power supply. We can vary the output voltage. Now how we can vary this output voltage? By varying this variable resistor. Now remember that if R1 value is not specified in the example, we have to take it as 240 ohm. This is the standard value, and through this third terminal adjustable current flows. Okay, so this much you have to remember in this LM317. Now next step is you have to remember the formula for output voltage. So formula for the output voltage in this regulated power supply or variable power supply is V output is equal to V reference, or instead of V reference you can write 1.25 because it is fixed, into 1 plus R2 upon R1 bracket close plus I adjustable multiplied by R2. This formula you have to remember always for LM317 and LM337. Remember that R2 whatever is given here means whatever the variable resistor is connected, that should be in the numerator. Okay, now first these two things you have to write always while solving the examples. Now let us see which are the given things and what is needed to be solved. First, adjustable current is given as 100 microampere and output voltage range is given as 5 volt to 15 volt. Means output voltage must vary from 5 volt to 15 volt. So we can say that 5 volt is minimum output voltage and 15 volt is maximum output voltage. And design this circuit means find out the values of all the components. Now IC we know, R1 value we have to take as fixed value 240 ohm, and now only one component is remaining, that is we need to find out the value of R2. So what we have to do here, first we will put V output is equal to 5 volt, minimum value of output voltage, and for 5 volt we will find out value of R2. Then next, for V output equal to 15 volt we will put V output equal to 15 volt and then we will find out R2 value. And this is the solution of this example. Let us move forward. Okay, so third step is let us find out the value of R2 for minimum output voltage. Now minimum output voltage is given as 5 volt. So 5 is equal to 1.25, 1 plus R2 value is unknown, R1 value is 240 ohm, plus adjustable current is given as 100 microampere. Micro means 10 raised to minus 6, needs to be converted into ampere, multiplied by R2. Now only R2 term is unknown in this case. You have to solve this. Okay, so let us first solve this bracket. So 5 is equal to, we have to multiply these two terms with this 1.25. So 1.25 multiplied by 1 will be 1.25 plus 1.25 multiplied by this term. So it will be 1.25 R2 upon 240 plus next term as it is. Now can I write 100 into 10 raised to minus 6? It is nothing but 1 into 10 raised to minus 4 into R2. Okay. So now you can see 3 terms are there, 1, 2 and 3. Okay. Now from these 2 terms we can take R2 common, and this term is again additions are there, sum is there, we can transfer this 1.25 on the left hand side. So 5 minus 1.25, this term I have transferred, and out of these 2 terms let us take R2 common. So inside the bracket what will remain? 1.25 upon 240 plus here 1 into 10 raised to minus 4. So if you calculate it, 1 into 10 raised to minus 4 means it will be 0.0001. Okay. Now solve these 2 things and this one. 5 minus 1.25 will be 3.75 is equal to R2 inside the bracket. Do this division, 1.25 upon 240. It will be equal to 0.00520 plus 0.0001. Now add these 2 terms together. It will be R2 into 0.0053. Means it will be R2 multiplied by 0.0053. Now multiplication is there, transfer this on this side. It will be, I will just interchange first. It is R2 multiplied by 0.0053 is equal to 3.75. I have just interchanged right hand side and left hand side for the understanding purpose. So R2 will be equal to 3.75 divided by 0.0053. And if you divide these 2 terms, you will get R2 is equal to 707.54 ohm. Okay. So R2 value should be kept at 700, near about 708 ohm, so that we will get output voltage is equal to 5 volt. In similar way, let us find out for V output maximum. Okay. So V output maximum is given as 15 volt is equal to 1.25 into 1 plus R2 value needs to be found out. R1 is 240 ohm plus I adjustable is 100 into 10 raised to minus 6 ampere into R2. Okay. So let us solve in the similar way as that of the previous case. Multiply this bracket with 1.25 first. So 1.25 multiplied by 1 plus 1.25 multiplied by R2 upon 240 plus 100 into 10 raised to minus 6, it will become 10 raised to minus 4 into R2. So again similarly what we are doing, we are taking R2 common in between these 2 terms, and 1.25 I am transferring on the left hand side. So it is 15 minus 1.25 is equal to R2 common 1.25 upon 240 from this term plus 10 raised to minus 4 will remain from the second term, but 10 raised to minus 4 is nothing but 0.0001. Okay. So 15 minus 1.25 is how much? 13.75 is equal to R2 into 1.25 divided by 240 is 0.0052 plus 0.0001. Now solve this bracket, add these 2 terms. So it will become 13.75 is equal to R2 multiplied by 0.0053. So again R2 will become equal to 13.75 divided by 0.0053. So 13.75 upon 0.0053. So value of this will come, so value of this will come as 2594.34 ohm, means you can convert it into kilo ohm, so it will be 2.594 kilo ohm. So this is the solution, and finally you can once again draw the circuit diagram. Okay, after finding out the values of R1 and R2 or all the values of the components, finally again you have to draw the circuit diagram, because R1 value we have kept at 240 ohm, V output it is given as 5 volt to 15 volt, it is variable, and R2 is a variable resistor and its value we have calculated as 707 ohm to 2.59 kilo ohm. This should be your final circuit diagram, and this is all about the design of the regulated power supply by using LM317. Thank you.